thanks so much for coming tonight. Today I want to talk to you guys about some of the work we've been up to, trying to understand human irrationality, all the crazy quirks and bad behaviors that you guys have, by looking at these guys up here, non-human primates or monkeys. And the first thing I want to do today is to try to convince you that this whole approach makes sense. I am, as you heard, a psychologist by training. I'm very interested in humans. They are the species that fascinates me. But I like to study humans and human quirks by turning to non-human primates. So I'll start by trying to convince you that that is a good approach. And then I'll talk to you about some of the work we've been up to trying to get at the quirks of human decision-making by trying to see if we can see some of the same decision-making quirks in our closest living relatives. And we'll talk about a couple quirks today. One, some early work that we've done on our lab trying to see if other non-human primates share our framing effects, and I'll explain what those are. And then we're going to talk about some new unpublished and kind of hot off the presses work trying to see if non-human primates share some of our pricing effects, and I'll explain those in a second. And then hopefully at the end, we will get to this big question about what parts of human irrationality might be unique. And the preview is that you're going to see that sometimes we humans are not necessarily uniquely smart, but in fact uniquely irrational. And so that's what you have in store for today. But first, why does it make sense to study monkeys if you're interested in humans? I get this question a lot. In particular, I teach classes to undergrads, and they talk to me, and they realize I don't really care about monkeys that much at all. I'm perplexed by human behavior, and they say, why do you hang out with monkeys all the time? Why do you do this? It's very, very intuitive for me, and so I've tried to come up with a way that I can express it so that it's intuitive for you too. You're meeting people for the first time, which hopefully some of you did tonight if you're mingling, right? And you are trying to get to know this new person that you've met, and luckily you are a human. You have human language. You have the ability to talk to them. The question is, what questions do you ask? Trying to figure out what this person is causally like, what do you ask? And this is audience participation part. Scream it out. Scream it louder, please. Favorite color. I think I've heard it out there. I'll call it there. Which is the one question I think I usually get first. You guys are more creative. But what is this question? Where are you from? Right? You meet somebody for the first time, you ask, where are you from? Already today, I've met a few folks in the museum staff, and I've been asked that question by about 3 or 4 of them. We always ask this. Why? Well, I think we ask this because it matters. It tells me something about who you are right now as an adult, older human if I know something about where you are from. If I find out that you're from the city versus you're from Jersey versus you're from San Francisco or Shanghai or the very same street that I grew up on, it tells me something really important about who you are as an adult, even many, many years later. Where we're from tells us something really important about who we are. The claim that I want to make today, and the thing that feels so intuitive to me, is if we ever want to understand this crazy complex thing that is human cognition, that is the human mind, we're going to have no hope of doing that just by studying adult humans. We need to figure out something about where all these cool things came from in the first place, and that's going to give us some really rich insight into where we wound up. And so we take the same approach that we use when we're meeting people for the first time to try to get at what it means to understand something about the human mind. And so when you take this where are you from approach to study the human mind, if you're thinking of the where are you from approach from an evolutionary perspective, then what you want to do is go back through evolutionary time and study all these guys who were our phylogenetic ancestors. You'd want to say bring, Australopithecine into the lab and ask him, how does he make sense of the world? Although there's a problem with this approach that if you're just hanging out in the museum, you might not realize, because while Australopithecine and Homo erectus and all these guys are well represented in the Hall of Human Origins, they're not really well represented in psychology labs because most of them are in fact actually dead. We have fantastic access to their bones, but it's hard to do decision-making studies with a bunch of femurs. And so we're left with a problem of trying to study this issue of where we're from because we don't have access to the guys that would tell us the most about this. We have to use a bit of a proxy. And the proxy that we tend to use in our lab is to turn to our closest living primate relatives. They're not our direct ancestors by any means. They've been on their own evolutionary path for a while, but they're the best hint we have from living species about what we can know about where we were from. And so now I'm going to give you guys a fast crash course on your own primate order. This is your very extended family tree, those guys that might not be in the family photo albums. But here is the primate tree, and what we try to do in our lab is study all of the different branches on the tops of the trees. And I've worked with all the different groups up there, but today you're going to hear most about the guys that have been in our economic studies, which is this branch right here. It's a branch of New World monkeys who broke off about 35 million years ago, and we represent the New World branch by studying this guy, the brown capuchin monkey. Up until very recently, we had a group of brown capuchin monkeys at Yale University. They lived in kind of a big zoo enclosure, and we could kind of get up close and personal with them to study their decision-making in a laboratory setting. But the goal is to try to use this guy to figure out a slightly bigger problem, which is, how is it that monkeys think about the world, and do they think about the world in any of the same ways as we do? Now, most of the time, if you guys go to a talk by somebody who studies what I do in my field, comparative cognition, comparing cognition in humans and animals, you'd be looking and hearing about answers to questions of whether or not other primates share the kinds of smart abilities that we have, making sense of the numerical world, and other animals know something about counting. And there's lots of work in the literature suggesting interesting hints that other animals are, in fact, sometimes smarter and more like us smart humans than we expect. In fact, if I was giving a different talk, I could talk about some of the work my lab has done trying to look at whether other animals, in fact, do count, trying to see whether, in this case, rhesus monkeys can track small numbers of objects. The fast answer to this question is yes, they can, but only up to small amounts, so some rudimentary number ability. But that's one smart ability we could look at. We could also look at a different smart ability, something about our rich understanding of physics and the fact that we know certain properties about how physical objects work. So I could give a very different talk about the work we've done trying to see whether lemurs, in this case, know something about tools and whether they know something about the properties that make a good tool. The answer is yes, they do, which is kind of surprising since they don't use tools themselves. You can be good at understanding tools without using them, which is cool. But these are all the kinds of things we could study to kind of see whether other species think and are smart like us. And I think up until about 10 years ago, this was really the field of comparative cognition. We took these smart things that humans did and we asked, do other species do that too? But I hang out with a lot of humans, and while it's true that humans do sometimes do smart things, the thing that perplexes me more about humans is the fact that we are this crazy species who has museums and human language and technology, yet we're not always as smart as we might like to think. And this got our lab started on this question of whether or not we could start studying the origins of some of these dumber biases. Could it be the case that we are irrational in some respects, not because we've had bad experiences or bad teaching, but because there's something in us, some part of our phylogeny that allows us to express these irrational biases? This was the question that sort of started the line of work I'm going to tell you about today, and in part because we began this work around the time of the financial collapse, where all our economic biases were in the news. We said, well, maybe this is a domain where we should start. This is obviously a domain where humans have some problems, and this might be a spot where we could really find uniquely irrational human behavior. And all of this work on economic biases in monkeys was done with two fantastic collaborators, my graduate student Venkat Lakshminarayanan and my colleague Keith Chen, who's an economist at the School of Management. And what we did was we took some insight from famous work on irrational biases in humans, and if you need a wonderful primer on this, you should check out Danny Kahneman's fantastic book, Thinking Fast and Slow, where he describes in detail and in wonderful examples all of the kinds of quirks you see when humans are making decisions about money, and all the spots where we're more irrational than we should be. And so for those who haven't already checked out Danny's fantastic book, I'm just going to give you one example of your economic irrationalities in action. Imagine for now that someone in this audience says, let's run an experiment. I'm going to give each of you in the audience $1,000 right now. And really play along. Think, what would you do if you had a $1,000 windfall just tonight? But it gets better than that, because now you have to make a choice about how to make more money. You can either take a risk. I'll flip a coin that's up here, and if it comes up heads, you get $1,000 more. Tails, you're going to get nothing. So that's choice number one. Choice number two is you could just take some more money from this donor with certainty. You could just take $500 with certainty. And so here's more audience participation. How many go with take a risk? Show of hands. How many go with play it safe? Show of hands. You guys are just like Princeton undergraduates who Kahneman tested. They too play it safe. There's nothing irrational about this. This is just being a little bit risk averse. What's irrational is what happens with a slightly different framing of exactly the same outcomes. So reverse time, imagine I haven't mentioned anything about this, but now I'm going to give you the option of getting $2,000 from this rich donor, except there's a little bit of a problem, which is that too much money was given out, you have to give some money back. But you get to decide how you give it back. You can either give it back in a risky way. I'll flip a coin. If it comes up heads, you lose $1,000. Tails, you'll lose nothing. Or you could just give it back in a safe way. You could just hand the guy back $500 with certainty. And now I'm getting a different measure of audience participation, which is smirking, which is a funny thing we do when we see our irrationalities in action. But perhaps some of you are like Princeton subjects, and you're realizing that, in fact, now it seems really a good idea to take a risk. You might not have to lose anything. This seems like a great idea. What's irrational, of course, is that if you're doing the math, the outcomes you have up there are exactly the same as the outcomes you have down here. Why are we shifting our preferences? That is what is irrational. And it turns out this scenario is identifying a couple different biases in action. One of them is what's known as setting reference points. And this is just this idea that if you're a pure economist, you would like to think that we should make all our decisions in a very absolute way. We should ask questions about what would maximize our absolute wealth or absolute happiness. But it turns out we just don't make decisions like that. We don't think in absolute terms, we think in relative terms. And this is what you're seeing in those scenarios. When you start with $1,000, getting a little bit more sounds good, getting $1,500 sounds great. But when you start with $2,000, getting $1,500 sounds just terrible. And this is because we're not thinking in terms of absolutes, we're thinking of changes from a particular reference point. And you can get the sense of this by thinking, imagine you leave here. You guys, this joke works much better when I'm not in New York, but imagine you leave here and you get a parking ticket. There's like one dude in the audience for whom this is a relevant scenario, but imagine you get a parking ticket. What would happen when you got the parking ticket? You wouldn't calculate your entire net wealth level because of the parking ticket and subtract it. You would just say, oh no, $50 down the drain, this is terrible. And the magnitude of emotion you would experience if you were a person who had a car and got parking tickets in New Haven all the time, like you do, would be an example of the second bias in action, which is a phenomenon known as loss aversion, which is that we really don't like going into the red. We like to avoid it so much that it sometimes causes us to do somewhat irrational things, like perhaps taking on more risk than we might otherwise have liked. And this is what happens in the second scenario. You're so loss averse that you're willing to take that risk just for the possibility that you don't lose anything. And these two biases in action play out in all kinds of different experimental scenarios, but we also see them in all kinds of funny spots in the real world. One of the spots we see these two biases in action is a puzzle that economists refer to as the equity premium puzzle. This is this idea that over time, you would have been better off investing just in stocks, because even though stocks go up and down, on average, they give you a better return. Yet if you look at most portfolios, people are over-investing more than they should in bonds, which don't yield overall as high, absolutely as high a return. What's going on? Well, if you have stocks, you know that sometimes the stocks go up, but they also sometimes go down. The idea is that the magnitude of how we feel that loss when the stocks go down sometimes make us ignore the actual output on those stocks, causing us to invest more in bonds that go up slowly but are a little bit safer over time. We also see loss aversion in action in the housing market. One of the reasons the housing market has slowed down is that people tend to hold on to houses that aren't selling below the rate that they purchased the price for. This is setting a reference point. You set a reference point level of your condo. You think it's worth that. The market goes down. You don't want to sell. And that means you're holding on to properties in markets that are losing value the fastest. Loss aversion in the housing market. But the scariest example, I think, is in fact that we see these kinds of biases on the golf course too. Dun, dun, dun. I mean, this is the thing economists want to fix, is biases on the golf course. But what do I mean here? Well, if you're a golfer, you know that the absolute thing you need to do to be good at golf is to get the lowest score on every hole. But you also know there's a very salient reference point, which is par. And it turns out that even on the PGA Tour, par messes golfers up. When they're putting and they have the possibility of going over par, it feels like a loss to them, and they end up putting more riskily than they should. Two Wharton business school professors tried to analyze the amount that PGA golfers lose, and they estimated the loss from this risky putting being about $1.5 million across the whole tour. Dun, dun, dun. It's even on the golf course. But the question we had was, is it outside the human species? I mean, it's robust in our species, but if we gave the capuchin monkeys that we work with money and had them make choices over these risky bets, would we see anything like the same sorts of phenomena? And this was where we ran into a methodological problem, because you guys don't hang out with our capuchin monkeys, but in fact, smart as they are, they don't actually use money. So we were kind of at square one with figuring out how on earth do we test this. Well, we had an interesting idea, which is, well, maybe we could introduce the monkeys to their own form of currency. We could teach them that they could trade it with people for food, like in a market. And if we did that, who knows, maybe they'd understand something about it, and maybe then we could ask them about loss aversion and so on. And it seemed like a bit of a crazy idea, but as many crazy ideas do, it seemed to have worked. And so this is what it looks like after we've introduced the currency to the monkeys. Here's Mayday, one of our monkeys. The monkeys live in a big sort of zoo enclosure. They tunnel out to a small part where they can be by themselves to do the studies. And here's her handing over tokens for pieces of food. Here's a video. This is by my grad student, Venkat, who missed his calling as a French New Wave film artist. But here's monkeys trading tokens. That's Felix, our alpha male. Here's Jill trading tokens. The miraculous thing was that they got really good at this with individual people. And so we said, well, are they treating this anything like money? Are they paying attention to things like expected value and risk and all the stuff that humans do pretty rationally? And so to test this, we said, well, rather than have them trade with just one person, let's put them in a real market where we can vary prices and vary what they're buying and see if they do all right in that. And so our little primate market was born. The way it worked is that each monkey always comes in and gets a little wallet of 12 tokens. They meet 2 different experimenters who are college students in the lab who dress in different clothes and sell foods to monkeys at different prices and different kinds of food. And so everybody comes in and gets a wallet. The 2 traders are going to kind of move to either side of the monkey's enclosure. They'll show the monkeys what he can buy in a little yellow dish. The monkey will make his choice. He hands over the token. That trader is going to pay the monkey the food. And then this keeps going till the monkeys spend all of their tokens. And so here's just one experiment we did to see if the market works. Just do they pay attention to how much expected value they can get? Do they shop at guys who give them better deals? And so imagine you're a monkey and you meet Kirk, and you can see that Kirk is holding a single grape, so that's what he's selling for 1 token. So he seems like a pretty good deal because monkeys like grapes a lot. But then you meet Justin, who seems like a better deal. He's offering 2 grapes. And the question is, do the monkeys shop at who gives them the better bargain? And so here's another video. It's kind of a monkey eye view, so heads are cut off. But here's Honey waiting for the market to open. They're sort of impatient. And so you can see not just Honey, but about 90% of our monkeys ended up shopping at Justin. Suffice it to say, the monkeys pick up on many things in our market that we pick up on when we're being pretty rational. They pay attention to expected utility, they pay attention to price, they pay attention to risk. My colleague Keith Chen is fond of saying, if you looked at the monkeys' data in some of these studies and you didn't know they were from monkeys, you'd think they were human traders. And so this was pretty impressive. We didn't think we'd get this much of a match, but the cool thing is it allowed us to ask the question we were really interested in, which is, are the monkeys going to be irrational in the spots where humans are irrational? And to do that, what we did was to give the monkeys basically the same scenario that you guys did. Here's the first one that you did, where you're getting extra food than you expect. And so to test that, we introduced the monkeys to 2 new traders, Vlad and Wesley. They each look like they're giving 1 grape, but the monkeys are going to get a bonus. From Vlad, they get a safe bonus. Every time he is traded with, he adds a single grape to give the monkeys 2, so he's like getting the $500 safely. The monkeys also meet Wesley, and they realize Wesley's risky. Sometimes he doesn't give any bonus, but sometimes he gives a big bonus of 3. And so if you're doing the math, you get exactly the same scenarios. You're all giggling. Question is, what do monkeys do? Well, just like Princeton undergraduates and you guys, they tend to play it safe. They mostly shop at Vlad. But that could also just be because the monkeys are kind of a little risk-averse, just like us. What happens in this scenario where the monkeys are getting less than they expect? What happens when they get losses? And the joke in the lab is that nobody likes to be the jerk that has to take the grapes away from the monkeys, but sometimes you have to do it for science. And so the monkeys meet the 2 guys doing it in this case for science, Alex and Venkat. Alex looks like he's starting with 3, but he's a safe loss, so every single time he takes 1 away to give the monkeys 2. Then the monkeys meet Venkat. He's a risky loss. Sometimes he doesn't take any away, and sometimes he takes a lot away to give the monkeys 1. And so you're giggling, so you get the math. You've done this. Are monkeys as irrational as us? And the surprising answer we got seemed to be, yes, they are. They tend to shop at Venkat. If you're a data kind of person, here are the actual graphs from the monkeys' choices. I'm plotting how often they go with the risky experimenter. And the blue is the first scenario you saw. The orange is the second one. And one thing to notice is that the monkeys vary a lot. We see a lot of individual differences. People always want to ask, like, who's this first guy who's risky all the time? Turns out he's our alpha male. So be that what it will. But the cool thing to note is, in fact, all of the monkeys, even our alpha male Felix, tends to show what we call the framing effect. All of them get more risk-seeking, go for more risk when they're dealing with losses than when they're dealing with gains. And this was the first hint that we got, that it seems like on some of these economic problems, the monkeys are acting just as irrationally as we are. We later saw that they seem to treat losses and gains about the same way, where losses seem to loom about twice as large as gains. We showed that they seem to overvalue objects they have, sort of the bird in the hand is worth more than two in the bush. They seem to show that effect as well. And a lot of the problems we tested them on, they seem to be just as irrational as us. And I'm happy to answer more questions about that. But I thought I would deal with a slightly more interesting question, which are the cases where the monkeys are more rational than we are. And this was the kind of thing we were thinking of as we started a kind of new line of studies to just sort of probe a bit, are there spots where people are uniquely kind of dumb when it comes to the choices we make? And this led us to start doing some work on what's called price effects, or effects of price on value. And this is work done with two undergrads at Yale, Nick Buttrick and Ria Catapano, who did this work for their senior honors theses. But what's this pricing effect? Well, the pricing effect is that I can affect your subjective preference, your actual taste of a particular good, by telling you something different about its price. And so if the Museum of Natural History wanted to run a study, they could have just left the prices out of different wines that you were purchasing. And if they were holding the same wine and calling it $100, it would taste better to you than if they were giving you exactly the same wine and calling it $10. And you can see almost doubling of preference when I just lie to you and tell you the wine costs more. You might think these are just cheesy undergrads who don't really know anything about wine and they can get messed up. But in fact, they're not just saying they like it more. If you use brain scanning fMRI techniques and you look at their reward regions, the regions of their brain that would fire if they had access to things like sex or money or really sweet foods, those regions fire differently for exactly the same wine, just told that you're charging more for it. And so what we wanted to do was to see whether we could see the same effects in monkeys. And the cool thing was that from our first set of studies, we knew that the monkeys understood price. In fact, they understood price so well, my economist colleague was like, you can't even tell their data from a human's data. And so we tried to do something a little bit different. This time we introduced the monkeys to new brands of food, just to see if we could get the price effects there. And so now the monkeys meet experimenters who are selling little goods in boxes. So they meet the kind of Clover brand and the Moon brand, and their monkeys are getting little boxes of cereal. So it's the same food, but it's kind of a different brand. And we did this because this is the spot where humans show all these pricing effects. Typically, it's different brands of the same kind of thing, where you can't tell the difference very much. But the monkeys meet these two guys, and they get to choose between them when they have equal price. And then what we do is we make one of the goods a little bit cheaper. So now the Moon brand has just gone on sale. You get 3 times as much food from the Moon brand as you do from the Clover brand. So this guy has suddenly become cheap. This guy's still pretty expensive. And if the monkeys understand price, as we think they do, they should shift their consumption more to the cheap good. It'd be like if your favorite brand of wine, if you have 2 wines you like equally, one super went on sale, you might buy more of that one when you went to the store. And so we wanted to see if the monkeys did this. Here's me representing how often they choose the good that's eventually going to be cheap. Here's what all the monkeys do. Before one's cheap, they just don't care. Once one becomes cheap, they all shop and just buy that good almost totally. So they get price and they get this information. Question is, does it affect how much they like this thing? When they find out some novel good is really cheap versus it's really expensive, does it affect what they actually like? And so to do that, we did a different version of the study. And I'll explain the setup first, and then I'll show you what we did. So imagine that the monkeys come in, and they get to shop just at this guy, so they don't have a choice, and they buy from the Horseshoe brand. They realize, Horseshoe's kind of expensive. I only get one. They meet a totally new symbol, which should be a new symbol, but imagine it's Horseshoe or something. They meet new symbol guy, and they shop at him, and they realize, wow, this is really cheap. And they shop at this guy, up, he's really expensive. This guy, up, it's really cheap. And so now we do the interesting part of the experiment, which is now imagine that instead of you having to purchase the wine, it's just free. And so you might like the $100 wine at the Museum of Natural History better, but maybe you don't want to pay $100 a glass for a tiny glass of wine. But if all of a sudden a donor came and said, let's just give away free wine, which wine would you pick? Would you pick the $100 one or the $10 one? And this is the choice we give the monkeys. Now they come in for their normal testing, except they don't have a wallet. But there's no traders. The boxes of the foods are there. They can just eat as much as they want. And the question is, will they selectively eat the expensive one? In other words, will they have now come to prefer the one that has become expensive? And so I'm going to plot for you how often the monkeys pick the cheap or expensive good. Cheap's in yellow, expensive is in orange. And this was basically the flattest perfect effect of no effect we could have possibly seen. The monkeys just don't care. And so we said, this is puzzling. Maybe it's because we did these weird cheap and expensive brands. We've now tried it with cheap and expensive novel foods, cheap and expensive familiar foods. They just don't show this effect across a bunch of studies. Seems like they kind of just don't care. This is the first irrationality we've seen that seems to be true in us, but not in them, even though they understand price. And so we're trying to figure out what's going on. Well, it can't be that they don't understand the price, because we know they get that in a way that an economist might respect. And so we worried it might be something else. We said, well, maybe the monkey market is kind of a little bit different than our market. It doesn't really have supply and demand in the same way. Maybe they're missing something critical in the way they learn their market that we kind of get that makes us think that expensive goods usually are much better. But we worried that we were missing something with that purely economic explanation. And the reason we were worried is this. I started thinking, what do I think when I'm buying an expensive wine? Am I thinking about supply and demand and like all these economics principles that I forgot from like my freshman year of college? No, I'm thinking rich people like this expensive wine. I'm thinking of what other people are thinking. And we started thinking that maybe the monkeys are using the price as a cue to what other people think and what other people believe. And we had this intuition in part because we were watching the news. This is the news on the Apple store downtown when the new iPhone 5 is coming out. And this is the morning of, and people have been waiting very uncomfortably outside. Hopefully none of you are in this picture in the audience. I feel embarrassed for you, right? But why are these people doing it? Well, they could like the iPhone just because it's really expensive, or they could be taking as a signal of the price of the new iPhone, which, mind you, is basically the same as the iPhone 4, whatever it is, but more expensive. They could be taking the price information, but my guess is that the price is a signal for the social information. It's a signal that other people like it. Important people like this thing. And so we worried maybe this is the spot that the monkeys are differing from us. Maybe they're not as susceptible to the dumb social things we see other agents doing. The interesting thing I think we're learning from our work on irrationality is that there do seem to be some spots where we are more irrational than other animals. And in particular, it's the spot where we're irrationally swayed by the actions of others. From really extreme prices of wine that aren't very good to problem solving in sometimes not so creative ways, it seems like one of our irrationalities is that we overweight the ways that other people solve problems and other people's attitudes and beliefs. And this has become the thing about human irrationality that I think scares me even the most. But just since I need to give you guys time to ask some questions, I hope what I've convinced you and what this all means is that if we go back to our kind of primate family tree, we've seen that at least some of the irrationalities that we see in the human species are exactly the same irrationalities that we see in other species too. And the neat thing is that these are two species that were related about 35 million or so years ago. And that suggests that some of these biases must have been there for a very, very long time, which raises questions about how dumb are they, are they useful for something? All kinds of stuff I think would be fun to discuss in the question period. But we've also seen cases where other species don't share the irrationality, where the irrationality, particularly since it's not there in chimpanzees, seems to have evolved very, very recently in the primate order. And that, I think, raises really interesting questions about what these biases are there for, what they might be good for, and why we might want to worry about them. And so with that, I'll give you my final thought, which is that I hope I've convinced you that studying the evolution of some of our duncier strategies is interesting, and that looking to our phylogenetic relatives is good. But of course, we've only been testing other primates so far. And what we're now doing in our new Canine Cognition Center at Yale is to try testing a species who might follow humans perhaps even more than chimpanzees, such as the domesticated dog. And we've just started Yale's first Canine Cognition Center, where we're bringing dogs from the community in to do some science with us. Here are some happy customers who've come in and had their dogs do some science, dogs of all different happy sizes. This is like the sign of true nerdy science squee when your dog gets a little mini degree from Yale. It's quite awesome. And I bring this up to tell you about some of the cool stuff that we're doing. It's very fun for dogs to come in, but also if you have a dog that is up for jumping on the Metro North to come up north for a bit of science, I highly encourage you to send him up. But with that, I'll shut up and ask some questions.